And a warm welcome to you all to this second webinar on lean innovation. As it is the second webinar, we had to decide, will we do an extension on the previous one, or will we have in fact a little the same as the last time. But as you know from lean, with some incremental improvements in the presentation. Why do I believe myself in lean? I think that's an important question. Lean, I've been involved in the lean area for over 5 years now. I've seen many benefits. I've seen organizations where they have a lot of profit from it, and seeing that, I think I really became a believer of it. When you look at lean, it's in fact a lot about common sense. You will see that during the lecture. The problem of lean is not the common sense and the principles. They are not that difficult. The problem is the implementation of it, and the culture change which is needed for it. I will come back to that later. During the presentation, I will talk sometimes about lean innovation, and sometimes I will call it lean product development. For me, it's almost the same. Lean product development is more focusing on the development area, be it mechanical, electrical, or software. Lean innovation is a bit broader. You will have to include marketing and portfolio management and stuff like that as well. Okay, let's start. So what's on the agenda? So I will tell something on why lean in innovation, something on the elements of lean innovation, and as I said, something on the implementation of lean innovation. But first, let's start where I come from. I come from Philips, you already know, and we define Philips as a global company of leading businesses creating value with meaningful innovations that improve people's health and well-being. So, an important part of this sentence is the meaningful innovation. So Philips is working on innovations a long time now, and we spend a lot of effort in it, and also on improving innovation. That's why Philips is an ideal place to learn how to improve innovation and also to apply lean techniques. Okay, so Philips is also a very big organization. There are 3 sectors, being healthcare, consumer lifestyle, and lighting, and there are some supporting groups. One of the supporting groups is Philips Innovation Services. That's where I'm from. And Innovation Services is there to help the Philips organization with its innovation. And we do that in different ways. We do that helping them creating ideas, developing equipment, making prototypes, and consulting. In the development part, we do this in a lean way. And in fact, when you look at our software development group, they are applying lean in software, which in software world is called agile programming. We apply it there for over 10 years now. So, as an organization, we do not only advise on it, or teach it, we also do it ourselves. Okay. So, now looking at innovation. There are, looking at innovation, 3 levels to turn. So, there is end-user driven innovation, there's the choices you make during your innovation, and doing innovation in a productive, efficient and effective way. Let's look a bit more into this. So, the first is end-user driven innovation. As innovation services, we help to discover insights for your innovation process. We help create new ideas, and when you have your new ideas, we help you with fast feedback on those ideas, and we help you grow your business in this way. The second part was smart choices. When you're in an innovation environment, you have to make all kinds of choices. Which markets, which products, what timing, which platforms, all stuff like that. Is it integrally robust? What do we do with suppliers? Do we insource or outsource? So a lot of questions, and where we help here is in road mapping, on strategic architectures, which of course is a combination, and on innovation planning. Next to this, we have what we call development productivity. And development productivity you can define in many ways. I used here a definition from Professor Cooper from the stage gate approach. And he defines development productivity as the profit achieved divided by cost and time to do a project. So if you want to increase your development productivity, you can work on the lower half. So try to reduce your cost, so by, for instance, removing waste. Or you can also speed up your time to market. Now, looking at this, there are several improvement approaches, and we apply them all within Philips. You have design for Six Sigma. You have the theory of constraints from Professor Goldratt. And you have the capability maturity model, which came out of the software world. And you have lean product development. And in fact, when you are looking at your own organization, and you must decide which way do we go, which approach do you want to apply. Well, I think you need combinations of this, because there are good parts in all of them. But today we will focus on product development. Okay, so why lean? Why lean innovation? So looking at lean, it started for the Western world with a book called Machine That Changed the World. It was in 1991, so a long time ago, 20 years ago. And when you look at that book, you will see that it's a lot about manufacturing, a lot about logistics, but there's also a lot about development inside that book. And we picked in the past already some stuff out of that book. For instance, concurrent engineering. That's typically a lean approach written in that book. But what you have seen in the world is that it picked up much more in the manufacturing area. So when you are in a factory nowadays, and you walk through on the shop floor, you will see the striping everywhere, you will see glass walls, you see the clean areas, typically all elements of lean. And when you look at the major player applying lean, Toyota, also Honda, so looking at that, you see that they did a lot in manufacturing, a lot of success, but they also had a lot of success with development. And you can see that by looking at figures again. And when you look at the figures, you can see that they are able to produce twice as much new models to the market compared to their competitors with only half of the force. So a productivity difference of a factor of 4, which is a very lot. So there was an investigation in I think 2000. So on looking at what were now the real differences between the Toyota business and Honda and the American business, as an American study. And you find some typical differences, and you see that here in the picture. What you see is that the engineering productivity is very high in the lean companies and very low in the traditional companies. And you might say that's very strange. And of course, only 20% productivity means in fact that only 1 day out of 5 is really productive. But you have to take in mind here that if I work on a project for more than a year and the project is cancelled, the whole year was not productive if I was not capable of capturing all the learnings I had in that year. So that's one of the causes why the difference is so big. Also, when you look at knowledge, you will typically see that in the Toyota company, they do it very systematically, whereas in the traditional companies, they do that much more on an ad hoc base. Also, you have some other things like unplanned design loopbacks, which you typically not see in the Toyota area, but typically see in our area. A design loopback, for instance, is when you start a project, you think, I have a nice concept, a nice idea, let's go for it. And after 2 months, you think, well, this was not a good idea, and you have to go back again. And then you have an unplanned design loopback, which is of course devastating for your planning, and it costs a lot of money. So there are other things as well, I will not go into them. So there are big differences looking at traditional and lean companies. I will come later to the elements which cause these differences. Okay, so as I said, manufacturing is a lot further. So why not just apply lean manufacturing methods? And in fact, it makes a lot of sense. sense applying lean manufacturing methods. I will show an example later. But when you look at innovation, it's typically quite different than manufacturing, whereas manufacturing is repetitive with short cycle times. Development is unique for every project. A project can take 1.5 years, so a long cycle time. So quite different. And also looking at variation, you typically in manufacturing want to keep out all variation. Whereas in development, you also want to keep variation low, but you know that you need variation to come up with new creative ideas. So you need iteration loops there. So why is it still very profitable to look at lean manufacturing? It is because the basic principles are in fact the same. And for me, the basic principle of lean, and I think that's a very nice definition, is solving problems for continuous improvement by people doing the work. So solving problems, seeing problems, solving them fast for continuous improvement, doing it better every time by people doing the work. So not a staff organization, but the people on the shop floor or in your design department. Next to that, there are some more other basic principles like go see for yourself, and not just trust the people coming to you telling what's going on the shop floor. Ask why, try to really understand the situation, and the last one, very important I think, show respect to people. I think that's very important in the lean area. So this a bit why lean. And let's go to some of the elements of lean. For that we made what we call a circle of lean product development. And what you see here is this circle, and I will go through all these steps. The problem with lean is you have to do them in concert. You cannot take one out of them and say, okay, now we are lean. You need more and even all of them to be a real lean company. So let's jump into that and see what's in it. So the value focus, the first one, the value focus. Why do you say value focus? Well, you want to focus your projects on the value you create for your customer. And when you do that, you can typically look at what is non-value added. So what does not add value for my customer? And one of the important things of lean is to remove the non-value added activities. We call them waste. And now coming back at the manufacturing part, as I said, you can use the principles out of the lean manufacturing part. Now we did it here. What you see in the picture is the 7 waste plus 1. It's a picture out of the manufacturing area, where you have typically waste like overproduction, too much production, waiting, you're waiting for materials, transport of goods, processing, so you over-process or process too high accuracy. Inventory, you have too much inventory, it's of course very well known, where you have the just-in-time principles to go after that. Motion, so the motion of a man behind the machine, and correction of parts which went wrong. So you can translate these wastes into the development area. And for an example, I've translated one of them, and it's what we call the waste of waiting. What you typically can see in development is that engineers sometimes are waiting for information. That can be information from a supplier, that can be information from a previous process step, like a requirement session. It can be waiting for information of the prototype department, of the test department. So people are a lot of time waiting for information. Also, it can be the other way around, that information is waiting for people. So you have information you created, for instance, a report on the customer, and it's lying around for a couple of weeks before someone takes it up. So in fact, you have then the waste of waiting for the information. And the last one, it's more for the managers listening. you have sometimes engineers waiting for decisions. So do we go left or do we go right? And that can be very strategical decisions, but the engineers are just waiting for that answer. And of course, they are spending that time well because they are behind their computer and they are working hard, looking at the internet, looking at all kind of new developments which once could have taken place. But in fact, they are waiting, but you cannot see it. And that's one of the problems with development. When you look at manufacturing, you can simply see it if a machine is standing still or if an operator is not working. And that's one of the problems within innovation, seeing the waste. So for seeing the waste, and there are more waste than we mention here, we also have a course training people in how to see waste in development. Now what I did is translate the manufacturing waste into the development area or the innovation area. But as I said in the beginning, the innovation is much more than development in the sense that it's a knowledge creating organization. So as knowledge is created, you also have another waste. And that's what we call the waste of knowledge. And I have some examples of that as well. So the waste of knowledge. Here are 4 examples of them. I will briefly go through them. The first one is what we call scatter. So you have, for instance, too many projects in parallel. So you are working on 4, 5 projects in parallel, and every time you switch between projects, you have to get the context of the new project again. And this context switching takes a lot of time. So if you have 10 projects, maybe you are only switching context, and you cannot add any value anymore. So another example is when you have not enough focus. For instance, you are disturbed by too many other things. And that can be, for instance, web mails or stuff like that, which come at any given moment and which take you off of your work. Another example is reorganizations. When you reorganize, people have to find a new place, have to find security again, have to find the new people they have to work with. So they have a lot of scatter there. They have to spend the time on these new things. So another source of what we call the waste of scatter. Another example is the waste of handoff. Handoff is when you give information between from one people to another, one person to another. And the most common example is in the development area, where you make your drawings and you have your set of drawings ready and you give them to manufacturing, you throw them over the wall, and manufacturing, they receive them and they say, well, what does he mean with this? Or this could be done in a smarter way, or this component we had a lot of problems with last time. So a lot of information which is in the head of the designer cannot be translated to the manufacturing guy. So this handoff it's about translating only a part of what you know. Another example there is when you have a task to fulfill and someone else is defining how you do your task. And again someone else is checking if you did your task well. So you have 3 people involving in one task. So typically Lean would say, bring those 3 together into one person. So let him decide how to work, let him do the work, and let him check his own work. Okay, so typically the handoff part was that. Our next one is what we call wishful thinking. Wishful thinking is about making decisions without facts or operating blindly. It's about making fast decisions, saying, okay, we have to decide, let's go left or right. Well, belly feeling says right, let's go for it. And after 3 months we say, well, it was not the right decision and we have to go back. You see this kind of waste a lot, especially in development projects, but also, for instance, in reorganizations and in other stuff. Or IT implementations are very well known for this. I think one of the reasons why so many IT projects fail is that it is wishful thinking and that we did not think well in the beginning. The last one is what we call the discarded knowledge. So at the end of a project, you sit together and say, what did we learn during the project? And you have an evaluation, but your head is already in the next project. And if you really want to capture the knowledge, you have to do it already during the project. In fact, a lean approach for this is that you first develop your knowledge and then use it. And developing the knowledge means also capturing it and structuring it. Okay, so these are examples of the ways of knowledge. I go back to the circle, it's on the top half of the screen, and I go to the next one, which is visual management. And looking at visual management, you can say, why should you do visual management? Well, first of all, you can do it to get a quick overview of where we are. But I think more important is that you see more quickly the problems you encounter in your project or in your activity. For instance, when you have an Excel file, you see all kind of numbers, but you do not know which number is big and which is small. But you typically see on visuals in the lean area, with red dots are marked where is the real critical part. I have some examples later. What's also important is to focus upon the things which are getting out of control. And what's in control, just leave it and do not focus on it. I've shown that by the picture to the right, where you only look at the sides of the road and not at the center of the road. Okay, an example of visual management. So I have two pictures of that. One picture on the left, it's typically a management meeting. In this case, you see a group of managers, and that are department managers and program managers. And this is from a truck manufacturing and development and manufacturing organization. And they discuss all the projects. And what they made was a big board in which they have on the horizontal lines all the projects and the vertical line all the departments. And you typically see that they cross sometimes. So when you see green dots there, they cross, there's no problem. When you see a yellow dot, you see there is a problem, but we can handle it. When you see a red dot, you know there is a problem and we have to do something with it. And this meeting, a stand-up meeting, every Monday morning, 8:30, discusses only the red dots. So typically an example of visual management. On the right side you see an example, which is a Philips example in fact from Singapore, from a household device, where they follow the development of a household device. And maybe again very small, but you can see some red dots there again. What they do here, for instance, is for this household device, they have some plastic parts in it, 8 or 9 plastic parts, which have to be manufactured in the sense that they may have to make molds for it and first out of tools of it. And they check the first out of tools and they follow them on this board. And you typically quickly see where are the problems with the molds. Okay, so some examples of visual management. Let's continue with the circle. So the next one, it's integral project leaders. And for those who are more in lean specialized, they are in many cases called chief engineers. A big example of a chief engineer is for me still Steve Jobs, who has typically a lot of knowledge on the products and on the marketing side and really can give the vision. And when you look at the conventional and the lean part, you see that in the conventional part we tend to have project managers who just follow the planning, who make presentations for the management, who nag engineers to meet spec, track deliverables. And you might say, well, this I do not recognize. I did a project last year, it was in France, and we came into the organization, we did an analysis of that organization, and one of the things we typically found was that the project leaders were people who were hired only for the job, and which only followed the project and had no technical background. And so for us, that was the first improvement topic for that company, to create what we call integral project leaders. So an integral project leader provides the vision, represents the customer, guides consensus, and provides the leadership. So typically a different role. Let's continue. Next one, this is also a very interesting one, I think. It's what we call teams of responsible experts. And there are 3 words in that sentence. So teams, really talking about teams working together. And that's why I took this picture of a surgery, of an operation. And that really has to work as a team. Everybody has to know its place. Everybody has to do his job 100% well. That's a real team working together. So I characterize it in 3 words, 3 sentences. Real expertise, so really know how to do your job. Sometimes we call lean and also agile programming a game for professionals. And it's not that easy to play this game. So lean is not that easy, not that simple. You have to be very effective in teams, and you have to have a responsibility. And this is also a difficult one. For me, you have 2 kinds of responsibility. You have your external responsibility and internal responsibility. External is for me managers saying to you, you are responsible and you must do this and you must do that and you must do this. And you say, okay, you say it, I will do it. The internal responsibility comes from the inside, and it says, okay, I do this job and I have a customer who waits for me, and for that customer I must do this. Otherwise he cannot do his job. And I have this internal responsibility. So, and that's quite a difference. Okay, let's continue with the circle. The next one is what we call the lean culture of continuous improvement. And this lean culture is best addressed in a report or a book from Womack and Jones called Lean Thinking, and it's in fact the blue circle. It's about identifying value of a process, mapping that process, and mapping the process can be the current state and the future state. And then you have a future state which you want to work to. And when you have this process, you have to create flow, make sure that it's running well, get what we call within Philips speed bumps out of this process so that it really flows fast and smooth. And when you have a small, fast and smooth process, you need to establish pull so that the process only starts when it's really needed. And the last one is called seek perfection. And that is, then you have your process in place that you are continuously trying to improve this process every day, making it better. And that's again a cycle. But that's what I call, and that's I think more in development than in manufacturing, work for a team where you bring together some people who recognize the problem and which you give a straight process to come up with improvements. And in that straight process, you do typically things as defining the problem, do root cause analysis of that problem, real why, 5 times why analysis, and determine countermeasures to solve this problem. We call that Kaizen teams. I think this is an important part, because if you are not able to do this continuous improvement via these kind of improvement teams, it's very difficult to implement value streams like you need them in a lean environment. Okay, let's continue. I have another slide on the lean culture, because another part of this culture is the mindset. The mindset of the people in your organization. And there are a lot of topics in this mindset. I've picked out 2 of them, and I've depicted them in this picture. So, a situation. You have a project leader who thinks, well, my project will delay, I see some problems I had. But if I tell it to my boss, then my boss will say, well, I do not like that, and maybe he will even fire me, or some other bad things. So what do you do then? You say, I will not tell it, and I hope that it will go well. On the other hand, you have the manager saying, well, in my department all projects are running well, and don't dare to tell me that the project is not running well. So if you have such a manager, then you think, well, I might hide my problem. So from a lean mindset, from a traditional to a lean mindset. So you have hide the problem, and within lean you say, okay, no problem stays hidden. You do that with visuals, but you also do that with this culture and the mindset of the people. And you do not say who is to blame when there is a problem. So the manager saying, well, who caused this? Which project leader? Which developer made that error? But you think, why did this go wrong? What can we do to improve this organization of this situation so that this will not happen again? What can we do to help this organization? These are two aspects of a lean culture. There are many more, of course. Okay, let's continue with the circle. And let's go to a more engineering part. This one we call set-based concurrent engineering. And what do we mean with it? Well, instead of a more traditional approach saying, I must develop a new product, I have a nice idea and a good concept, and let's start. And then start, develop, make it, test it, and think, well, this was not really right. And then you have your unplanned design loopbacks. So in the Toyota world, they work a bit different in the lean world. They say, well, let's split up this product or system in subsystems, and even sub-subsystems, or even more detail. And for every subsystem, we try to develop more solutions and try to experiment very fast. How can we solve this problem or this requirement? And when you have on this sub level, you try to integrate them on sub level and slowly try to integrate to an end solution. And when you then are at the end of the funnel, then the chance that you have the right product is much higher. So looking at this will prevent your loopbacks, but you at once will say, wow, but this costs a lot of more effort because you have to do much more investigation in the beginning. And that's true. But when you have this product at the end, you can say, now I want to make a high-end version or a low-end version out of this product. And then you can go back to your decisions you made earlier and say, if I make a high-end version, what choices should I then make? And then you are much faster if you were able, and that's the critical part, if you were able to capture the knowledge in those first phases on a very structured way. And you need two things, we think. You need knowledge briefs, or something like a knowledge brief, where you capture the knowledge of your solution. And next to that, you will find for each problem more solutions. You will have to find a way to compare these solutions next to each other. And that's where we brought in the trade-off curves. So you make a trade-off for every solution. Let's give an example. So for instance, when you look at, I take the car development as an example. Let's look at the thickness of a door. And when you have the thickness of a door, you can say I make it very thick or very thin. So I have more solutions, I can test those solutions. And I can define a trade-off curve for that. Because the thickness of the door, of course, has to do with the weight. And the weight has to do with the performance of the car and the size of the engine. So weight is a very important one. On the other hand, you have the stiffness of the product. So if you have a very thin door, it will feel very cheap. So you will not want that for a high-end car. So you can make a trade-off between weight on the one side and stiffness on the other side. And when you have such a trade-off curve, the next time you do a project, you can easily reuse this. When you have this in place and you make the next product, the next generation of products, then you can go back to what you have and say, okay, what do we already know and what is new in this product? And then you can say, okay, let's focus on what is new, do this process again, generate the knowledge, and then come up with a solution and reuse of what we already know. you can also let suppliers play a very important role in this. Help to involve them in these processes and let them come up with alternatives. If you do this in a structured way, you capture over time a lot of knowledge. And that's what's in the next picture. What you see here is the development projects, which are on the horizontal line, and the building up across the project of the knowledge. And in fact, over all the project, you build up the knowledge and you reuse the knowledge for every project. And what you typically have done here is two value streams. One value stream for the products and one value stream for creating the knowledge. And what I see, when I look at companies, I see they place a lot of effort on the product value stream and much less effort on the knowledge value stream. So they have the problem with people going away which are knowledge carriers or losing the information after projects. The first thing to do in this knowledge area is to recognize these two value streams and put enough effort and attention to this knowledge value stream. If you do that, you can get to the following situation where you have in your project a knowledge creation part and an execution part. And in the knowledge creation part, it will get over time shorter and shorter. And that's why you win time to market. And that was one of the goals we had in the beginning. And your execution will be much more stable or efficient because it's really standard work you are doing. It's reusing knowledge you know already. And also there you will win efficiency and time to market. So based on this knowledge, this approach, this set-based concurrent engineering, you can speed up your development processes. Okay, let's go back to the circle. I discussed most of them, some I had no slide of, but what you see is you typically need this whole circle to really implement lean product development. And one of the problems, of course, is where to start, how to start, and following it through over time and getting management focused on such an approach. Okay, let's go to the next part. It's the implementing part. So, looking at implementation of lean product development, I think it's very situational. If you are in a research kind of environment, you will of course start with the knowledge management because that's important in that area. When you are close to manufacturing in a kind of engineer-to-order environment, the knowledge part will be less important, but in most cases the speed of the process will be very important because it's very closely linked to chances in the market. So, highly situational. What I also think is it's important when you start with lean product development that you start looking at a real problem. Looking at, for instance, time to market. Or it can also be that your field call rate is too high, or you have quality problems, or total cost of ownership is wrong. Really have a problem. And that's because, as I said in the beginning, my definition of lean, solving problems for continuous improvement by people doing the work, it's good to really focus on problem and not to have generic things like, let's improve our communication, which is much more difficult, I think. Okay, so take a real problem. You can also say, I will take a real approach, like the knowledge-based development I was just talking about. Our last approach is that you say, okay, we do not have the problem, we do not want to start with knowledge-based, too complex. Then you can start with building up the culture of continuous improvement, starting by having those Kaizen teams in place and starting with real day-to-day continuous improvement. Okay, some examples I've encountered. That's one thing we encountered. It all starts with understanding the value stream. It starts with understanding the business. What are you really at? And I'm very happy to say that within Philips we have the Accelerate initiative, and part of the Accelerate initiative is to create end-to-end processes. And the end-to-end process thinking and removing speed bumps in the end-to-end process is typically a lean approach. So I like it very much as a lean guy. And with the films we say we have 3 core processes, being ID to market, market to order, and order to cash. And a lot of work is being put into that. And what you typically do then is take such an end-to-end process and put a lot of effort in it, in speeding it up and in getting it more efficient. When you take one of the parts out of this end-to-end process, for instance on the ID to market part, you more look at project level. And what you see here in the middle of the screen is an example of what we did of value stream mapping of a project. So we took a project, it was in Hong Kong by the way, we took a project and we really analyzed the project, tried to identify where were the problems, and then try to identify what could be a better process and identify improvement opportunities. And then you are working on project level. You can even go one level deeper, and I think in most cases you even must to really understand it, because every white paper you see on that picture in the middle, you can analyze and you will see you will find a process again. And you can optimize that process as well and really get into the process in, for instance, in a Kaizen team. Okay, so this is what we encountered as a good way of working. Let's go into another example. This is an example from our own organization where we have in the software development area we have what we call agile programming. And we do that for 10 years now, and more than 70 developers of that group are using it every day. In small projects, large projects, multi-site, multidisciplinary. If you are in this area, they apply things as extreme programming, Scrum, Kanban, and stuff like that. And what you see here on the picture is typically such a visual board I was mentioning, where you see the backlog, what we still have to do, the things which are in progress. You see the colors, green being done, red being, you have to spend attention to this. And what we learned there in this applying agile programming for software development is that the responses to the market are much faster. Let's have another example of another way of working, what we call the waterfall model. There I had last year an experience with a project. It was on knowledge management and a tool for knowledge management, which was specified, and a year later it was delivered as being, this is the tool. And then we looked at it and we said, well, this is missing, that is wrong, and this is not what we expected. And a lot of time had to be spent to correct it. If that would have been done in an agile way or a lean way, the project team would have checked every 2 to 3 weeks, are we on track? Is this what you want, customer? And the customer had to be involved during the whole process. And then it's also possible to quickly respond to changes, of course. And we even noticed that it speeded up time to market, it made the teams smaller, it improved the quality. So sometimes people are very afraid that we will get all kinds of defects in the software which are developed in an agile way. The finding we had is the other way around. It's less defects because the testing is much more direct. And of course, the last one, the customer, he is really involved and he really gets what he wants. So the end user satisfaction is much higher. So we have very good experience with applying agile in the software development environment. The next slide I have is in fact applying this continuous improvement with Kaizen teams I mentioned. And these are some examples where we applied it. It is on the right side you see the luminaire business within Philips. In the middle you see a bed, and on the right side you see a building. And the building I think is interesting because it's a company of architects which also apply lean methods. So it's not dependent on mechanical development or on software development. You also can use it in an architecture team for buildings. And what you typically see there is the following process. You do first a kind of value stream mapping. You start in the continuous improvement, you create the lean mindset, and you introduce the visual management. Okay, so let's summarize. What we have seen is that lean innovation or lean product development has proven results. It really addresses the culture in your organization, and this is not easy. This also takes a long breath. What we also seen is that we can learn from manufacturing, but we have to see that innovation is different and needs different approaches. We also seen that when you want to apply lean, your knowledge is key, and you have to manage your knowledge value stream. And the last point, what we have seen is that the implementation really depends on the nature of your organization. Okay, so these are some takeaways I think you can have. So for me, this concludes the presentation.